we're talking about geometric series. And we had a formula to find the sum of a geometric series as well. Here it is. We are still going to need to know the same things, A1. Actually, we don't need the last term this time. We just need the first term. We need to know how many terms we're looking at. And this time, we have to know one other thing, which is the common ratio. Now, the way that these geometric series sigma notations are written out, like this part right here, this expression right here, tells us everything we need to know. So make a note of this. The number that's in front of the parentheses is always your starting number. That's always your A1. The number that's inside the parentheses is your common ratio. That's what you multiply by each time. Then we use this number and this number to find n, right? We subtract and then add 1 to get the number of terms. So here our n would be 7 minus 1 is 6, plus 1 would give us 7. So now we have everything. And we can just plug it right in. So let's use that formula and find the sum. So our sum is going to be the first term, which is 4, minus the first term times the common ratio, which is -3, raised to the n, which is 7, all over 1 minus -3. Okay, so 4 minus 4 times, I am not going to pretend that I know 3 to the 7th by heart, so I'm going to plug it into my calculator. -3 to the 7th, and I get negative 2,187. Be careful when you put that in your calculator. You should get a negative answer. You might need to use parentheses around the -3. All over 4, right? 1 minus -3 is 4. Okay, so now the rest I'm going to do in my calculator. 4 minus 4 times negative 2,187 equals, I got 8,752. Divide that by 4, and it's 2,188. And that's our answer. So for this one, we didn't even have to do any groundwork ahead of time. Everything that we needed to do this formula is given to us. We have our first term, we have our common ratio in the parentheses, and then we subtract these and add 1 to get n. And again, if this formula looks unfamiliar and you're not sure where this formula came from, please go back and watch the video about geometric series, because that's when that formula is introduced. Let's do another one. Same thing. My sum of a geometric series formula is this. I'll write it here just in case you probably already have it written down in your notes. So we need to know A1, R, and N. So here is my A1. Here is my R. And my N is 5 minus 1 plus 1. So that would be 4 plus 1, which is 5. So now we just plug it all in. So I get 40 minus 40 times 0.02 raised to the 5th, all over 1 minus 0.02. So this is going to be a really small decimal here. 40 minus, I'm going to do 0.02, raise it to the 5th, and I got a very, very small decimal with a 32 at the very end. And I'm going to multiply that by 40. And I get 1, 2, 3, 4, 5, 6. It's a lot of zeros. I get it. All over 0.98. So now I'm going to multiply that out, or subtract and divide is more accurate to say. It's just calculator work now. I'm just being very careful to make sure I enter all of those zeros correctly. Divided by 0.98. Divided by, oh, I have to enter it again, so bear with me. 40 minus, so you should be entering it in your calculator too. Okay, divided by 0.98. And I got a long number. I got 40.8163264. So this might be a question where it would say to round to the nearest hundredth. And if we did that, it'd be approximately 40.82. And that's our answer. All right, one more. For this one, we're given a sequence in a table, and we have to determine the sigma notation of the sum for term 5 through term 12. So we just have to write the sigma notation here. So in order to write the sigma notation, remember, we have sigma from n equals, whatever number they give us to start and end. And then we have the first term times the common ratio, and it's always raised to the n minus 1 power, because that's the number of times I would have to multiply by r. It's going to be one less than the number of terms. So let's plug it in. So that means we're going to have sigma. On the bottom of the sigma is going to be, it wants us to go from the 5th term to the 12th term. So we're going to have n equals 5. On the top of the sigma, we'll have the 12, because we're going from 5 to 12. Our first term is 5. And our common ratio, what do I multiply by each time to move from term to term, is, oh, I forgot my negative, is -4. So my common ratio is -4. And then I have n minus 1 as my exponent. And that's all I have to do for this one. It doesn't tell me to actually find the sum, although we could, doing it the same way we just did the last few problems. But in this one, it just asks for the sigma notation for the sum. And so this would be it.